solve today's Leetcode daily challenge problem. And the problem is permutation in string. Okay. Given two strings, S1 and S2, return true if S2 contains permutation of S1 or false otherwise. Okay, let's start solving problem. We are given two strings, S1 and S2, and we have to return true if S2 contains permutation of S1 or false otherwise. Okay, just like obviously S2 will be bigger, only then it will be contained. If S2 is already smaller, then answer is already false. So we are given an S2 and we are given an S1, and we have to tell if S2 contains AB. The permutations of S1 are AB and BA. If either of them are present in S2, then answer is true. Otherwise, none of them are present, then answer is false. That's what the question is asking to us. Let's see. BA. BA is a permutation of AB and it's present in S2. So the answer is true. In this case, neither BA is present, neither AB is present. Then our answer is false. The constraints we are given is both of the strings are of length 10 to the power 4. So that means that we either have to solve it in big of n or big of n log n. We can't solve it directly by brute force and traversing the second string, or the most basic brute force is to generate all the permutations of S1 and checking if they are present in S2 by traversing. That will take us out to the power n into n. That will obviously be TLE. So we have to think of something better. Something better. Let's try the test case, and we will see if we can think something better. Okay, quickly, fast. Okay, these are our test cases, and we have to check if any permutation of S1 is contained in permutation in S2, which means that either AB or BA or is contained in S2. Okay, so for that we can just S we can traverse it. Oh no, we can maintain a window, which means that the size of any permutation of S1 will be 2. Okay, whether it's AB or BA. So we can just check AEI, ID, BA, AO, OO. So now we can just do this. But the problem is that there will be many permutations of S1. How can we check that? So the thing here is that we don't have to generate permutations. We just have to check whether in a two value window, whether in a two value window, the complete S1 is consumed or not. Just like whether in a k size window, the k is size of S1, whether the S1 is wholly consumed or not. If that's consumed, that means that it's a permutation. And if that's consumed, that is a permutation and the size is k. The size k window consumes whole S1. Then our answer is true. Okay. And if size k window, no size k window is present in S1, S2 that contains S1. Okay. Then our answer is false. So just we have to check two things. We can write in a better way in smaller letters. Just like whether S2 contains S1, then answer is true. As any permutation of S1, then answer is true. How we will check permutation? We will make a window of size k where k is size of S1, size of S1, and we will maintain a two pointers for that window and traverse that two pointers one by one over the string S2. Okay, just like L and here is R, where R size is R minus L plus 1, size of that window is, and RL and my two pointers. So I will just move window over this and check if our whole string is getting consumed or not. And how we can check that is consumed or not? We can do it in big of n log and big of log n. We can check that for a particular character in big of 1 or big of log n using map. Okay, using map we can check that. If the all latter is latter, we will make a map, frequency map for AB for S1. Okay, to check that if S1 is totally consumed or not. A map for S1. Okay. Okay. Then after that we will make a map for a sliding window. Map for a particular window. We will make a map. If that window's map is equal to map of our S1, then our answer will be true. And how much time complexity will take? It will take very less time complexity because we just have to traverse k times k window over this. That is n, where n is size of n is size of S2, n by k is the number of times our window will move over it. Okay, that much into 26 because there are only 26 letters possible. So our answer will be big of n in worst case scenario. So time we just have to move the two pointers over the whole string. So big of n, not k won't be there. Big of n into 26. Just we have to move that. So our time complexity will be big of 26 into n. Okay, and what will be the space complexity? The space complexity will be big of 1 because we are only taking 26 letters. Alphabetically, only 26 lowercase letters are possible. So that will be big of 1. So that's how we will solve the problem. Now let's do a dry run over a better example, not the small one. And then we'll just code it and you will be able to understand how I will implement the sliding window and map both side by side and compare them. Okay, now let's take a better example. I will create an example for you. This is basically a standard program where just we have to use basic concepts of sliding window and hash map. Sliding window is very important topic uh, for online assessment rounds of various companies. Sliding window is nothing just two pointers. Okay, now let's make a S1. So our S1 is assume our S1 is S P R and our S2 is any permutation of SPR is, let's assume we are using this permutation PRS. Okay, and S1 is given A P R A P R S T. Okay, so first we will record our S1 in our map, in our hash map. So we will make a 26 size hash table. Around that we will count down occurrences of S1's character, just like S is occurring S is occurring one time, P is occurring one time, R is occurring one time. Okay, and for that we will, for S2 we will maintain a sliding window with the help of two pointers L and R. The size of sliding window will be equal to size of S1, that will be 3. That is R minus L plus 1 is equal to 3. And we will maintain a hash map for a sliding window. While we are traversing, we will first record this in our sliding window, and every instant we will check if they two are equal or not. Then we will go ahead and remove this from our window, remove from this our map, and add this to our map. And again we will check, and again we will move our window to APR, remove R, add R, and check. Then again PRS. Then we will decrement A and increment S in our current sliding window, our current hash map, and the side by side checking. While we are at PRS, the only PRS is present in the our hash map, and we will compare this hash map with our S1 hash map. and we will check our answer is yes, true. So we will return true. If we are traversed whole string and we are not getting any match, then we will return false. So that's the basically the problem is. Now let's just code it. Okay, the size is S1. Let's write time complexity. Time complexity of problem is we go of n into 26, and space complexity of problem is we go of 1 because we all just have to use 25 letters, 25 alphabetical letters for a hash map. So this thing is clear. Okay, let's now move ahead. First, we make a hash hash table or hash map, whatever you can want. I will name it original for the for S1. This is a good practice. Naming your variables according to the problem. So original. Okay. Now I have to make current one, which we will use to traverse over our sliding window, traverse our second string, and I will start it from 0. And the first case is that if a simple case, if n is greater than m, then return false because that's not only that's generally not possible. How can n be greater than m? Then n will obviously not be contained in m. Or if n is greater than m, equal to m, and s1 not equal to s2, then also will return false. These are two base simple cases. Okay, and then let's record it in our sliding window. And our R will be at position n, and we will maintain a check which will compare both the hash maps. Okay, that's our check function. That will compare our the current map and the original map at every instant of sliding over the string 2 while r is less than n m. Okay, so now we maintain a window of size k, size window of size n, size n, where size is the size of the first string permutation, and we will Just check this again. And if it's not matching at any point, then our answer is false. So let's just test whether our case is code is running or not. Oh, we can make a vector if it's not satisfying. Oh man, this sucks. Oh, why it's returning false? Oh, I get it. I did a mistake below. I had to decrement it. Shit. So now this will run. Okay, this is running fine. Both of them are running fine. Then don't try to submit this. Oh, okay, I did a mistake. Don't have to. Now that's it. Oh, okay. So this is our lead code deletion for today.